We're preparing your live stream preview. Wait a moment. You're live, it says.
Okay. It's always a bit
Yay.
terrifying for some reason.
Okay. I'm going to
We're
shut
live.
down the
We're
Slack
really live.
so that it doesn't go pop, 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 pop. Okay.
Yes, I already shut down that. And I actually turned off my phone.
Which microphone are you using with the Zoom meeting? Which microphone am I using with the Zoom meeting? Yeah, that's the right one. Okay.
Yeah.
Am I using this one too?
Yep. I know how to get my Zoom on.
I wasn't saying that you weren't able to operate Zoom. I would never say such a thing. Clearly, this is where
It's more of a flash reference, a very bad flash reference that really kind of sucked as a flash reference.
you were such a nerd.
I am, and I hate admitting that I'm currently enjoying things from the DC universe, but yes, I am.
Such as?
The Flash TV show is
okay.
actually pretty good.
Yeah. People are saying they can't hear us. Is that right? We're silent.
Be sad.
Why would we be silent? What? Are you silent? Talk.
Maresy dotes and dozy
No.
dotes.
Can you hear Pamela?
Maresy dotes and dozy dotes.
Why is there no audio?
The universe hates us.
Okay. All right. So they hear you. Okay, great. And can they hear me? Can you hear me when I'm talking? Okay, great. And then the two of us together. Can you hear the two of us together?
Hello.
Oh yeah, something's oversampling or something. Yeah. Okay, great. People were saying they couldn't hear us, and I literally just lost it. I lost my mind.
Oh, poor Fraser.
I know, poor me. Okay, hey, Pamela.
Hey.
What's going on?
It has gone from being early spring, beautiful weather in St. Louis to it's summer. Like for those of you who speak Celsius, it's up around 30 today. And yeah. So that's about it. It's a hot day.
John Suffield was the one. He had YouTube muted, and he freaked me out. Okay, we're all right. Thanks, John. No, thank you for making me test and make absolutely sure that I know how to operate my technology, because that was actually very helpful. Okay. I'm going to say hi to some people. I'm going to say hi to... I don't know how many of these people are still around and have been banned, but I'm going to say hi to Bill Druin, Billy Gordon, Carolyn B., David Dunn, David Joseph Wesley, Dawn of Light, Eric Knapp, Eric Schneider, Giancarlo Traverso, Giselle Sabarin, Guido Bibra, Helg Bjorkhog, James Haney, Jimmy 1105 full. Trying to think if that was a word. Anyway, John Suffel, Johnny Zed, Night of the Round Fable, Curry the Vegan, Larry Beckham, Margot Robinson, Michael Jobin, Mig Mag, Nancy Graziano, Phil Wilcox, Physics Police, Richard Strazel, Rob Taylor, Sylvan Westby, Susan Murph, Tech Tang, Thomas Traniker, and Tom Van Scotter. And finally, last but not least, Warbash. Hey everybody, welcome to... I have so many screens. I was looking over at the other one. I have 4 screens set up now in front of me, and it's a glorious thing. I actually don't use all 4 for anything but just doing these shows. I do need them when they're doing the shows.
That's a pity. See, I have 2 monitors, both at home and on campus, and I've learned I no longer function with only one monitor, because the left monitor is where Slack and Twitter and Audacity and all of those things that move go to live. And the right monitor is where content creation happens. And my brain, if you try and combine those, it's just no, I don't know where to put things anymore.
Well, it's the same for me. Like I'm just not used to it. Like I've
Yeah.
got one monitor is where I run the broadcasting software. I got one monitor where I'm running sort of the web browser. I've got one monitor where I've got the input from your feed, and then another monitor where I've got the outbound recording software. I use Audacity, and so we have all these connected together. Anyway, so if you're wondering what on earth you've stumbled into, we're going to do a live episode of Astronomy Cast. This is going to be episode 416. We're going to be 416. You sure it's not 426? Anyway.
It's not 426.
It's definitely not 426. Nope, it's 416. So this is Fireballs from the Sky. And we're going to take, I don't know, as long as I feel like we've covered the topic to do it. This might be a short one, but maybe. And then we'll stick around and we'll answer your questions about space and astronomy. So
do you know what error code 416 is?
Error code? No.
It's requested range not satisfiable. And initially, Susie came back with like all of these cosmology ideas for today's show. And I'm like, oh, that's just opening things up for ironic disaster. So when faced with error code 416 or episode 416, it was my personal choice to identify something that was only so large so that maybe we could actually satisfy the range.
It's Richard Clark is noting that it's also Toronto's area code.
Okay.
Yeah. Richard Clark says, I agree. One monitor is not good enough. 2 is a minimum. Yeah, go for 4, Richard. Go for 4.
Kyle has 5.
This can handle 6, but I will need a different frame to go full to 6.
Yeah.
I could actually see one more just for being the output from the actual show itself. But we're just like, we haven't even really learned how to push this technology to its outer limits. So we'll probably have a place where we're going to have one for, like, we're going to bring in YouTube videos into the show and pictures and things like that. But Chad, our producer, is currently on vacation in Costa Rica. So it's just me. And I'm actually learning how to do all of the things. I'm like a one-man band. Okay. Let us begin.
Okay.
I'm going to press record. Are you going to press record?
I'm finding that window. I am recording. Hello, Preston. We have like 2 more episodes with you, and then we lose you into retirement, and we're going to miss you so much. I'm just going to keep saying these things.
Oh, thanks, Preston. Are you sure, Preston? Are you absolutely sure? Because we're really going to miss you, and you're going to miss this too. All right, here we go. Astronomy Cast, episode 416. Fireballs from space. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
I'm doing great. So I just got back from New Mexico. I got a chance to speak at the Bandelier National Monument, which is just outside of Santa Fe. It was unbelievable. It was so awesome. A big thanks to the folks at Bandelier for having me. Unfortunately, we had terrible weather. There was a lightning storm, and the rangers had these like portable lightning detectors, and they were like, oh, that one's 6 miles away, oh, that one's 3 miles away. Okay, everybody, we got to move inside. And they had these beautiful telescopes set up, and they got rained on, and so we couldn't have had worse weather. But I had a wonderful time visiting, and we had a sort of a cool show. I gave a cool show for a small group of people anyway, and it was a lot of fun. So all right, so let's get on with the show. So every now and then we look up and we see bright, fiery balls falling from the sky. Don't panic. These are just bolides. Sometimes they leave trails, sometimes they explode, and sometimes they survive all the way to the ground.
Okay, so you're going to have to re-record that. I'm so sorry. So bolides are only when they explode at the end. Those are fireballs. I'm sorry.
All right, we'll just leave this recording.
Okay, sorry, Preston. Sorry,
right.
Preston.
These are just fireballs.
Yep.
All right. I've been telling people that it's wrongly then. All right. Whatever. I like it when you catch my screw ups before they go all the way into the show, and then people give us a hard time. Okay, here we go. Every now and then we look up and see bright, fiery balls falling from the sky. Don't panic. These are just fireballs. Sometimes they leave trails, sometimes they explode, and sometimes they survive all the way to the ground. Pamela, have you ever seen a fireball?
I totally have. Back in, it was 1998, November, there was this amazing meteor shower. And that year, for whatever reason, there were way more fireballs and bolides than normal. And there was a whole group of us from the University of Texas, Austin. We went out to Bee Caves Observatory and we were lined up like sardines in a can, trying to keep warm as we lay on the concrete. And the meteorites, as they streaked across the sky, were getting several times brighter than Venus and casting shadows in some cases, and a fair number of them just actually exploded at the end of their passage.
Yeah, I've seen only one, and it wasn't that long ago. It was probably about 4 years ago when I was out with the kids and we were out stargazing, and we saw the sort of the around us, like it was as if like a flare went off, like it was very bright, and it was like the full moon suddenly was out, and we all turned really quickly, and we could see this really bright fireball going through the sky, and I think I heard a sound, but I'm not sure. Sometimes you can't hear sound. So anyway, it was just an absolutely stunning experience, and the only way to see it, I guess, is spend more time outside. What did I see?
Well, what you saw was a small chunk of something. Could have been space debris, could have been cometary debris, could have been asteroid debris. And as it passed through our atmosphere, a couple of different things happened. First of all, it got hot, and so that's a glowy thing. And in some cases where you see a lasting glowing tail behind your fireball, in that case, it has ionized a chunk of the atmosphere above 80 kilometers. So high up in the atmosphere, it's ionizing the particles it's passing through, leaving a bright glowy tail behind it. And sometimes they get so critically hot, and either vapor pressure builds up inside or something happens that causes this sudden tremendous burst of energy at the end, where you see this flash of death light, and in that special case you have a bolide fireball.
Now you mentioned like a bunch of things that can cause it, right? It can be something from space, but it can also be debris that human beings have put up into space. So what is the underlying object? How big are we looking at when you see one of these things, before it hits the atmosphere?
Well, the really cool thing about stuff like this, so first of all, just some definitions. Anytime you have something streaking through the atmosphere, that's a shooting star, a meteor, call it what you will. It's a small piece to a large piece of stuff. Now, if that streak that you see going across the sky is several times brighter than Venus, then what you're looking at, and technically we say it's magnitude -4 visual or brighter, in that case, you're looking at a fireball. And if that thing that you're looking at streaks across the sky and then explodes at the last second, in that case, what you're looking at is a bolide. Now, it could be any kind of stuff, but what makes it that fireball is how much energy it's able to release. And this energy can come from two different things. You either have a fairly big object, and by big, I mean you might have a piece of gravel. How exciting. Or bigger. Or you could have something smaller, but with a huge velocity relative to our atmosphere. The thing that always surprises me is just how different the velocities of different things hitting our atmosphere can be, because it's either something that's just like kind of sneaking up on the Earth, not going that much of a different velocity than us. Or it could be something where it has an orbit the opposite of the Earth's around the sun and a head on collision occurs. So in some cases, it can be 25,000 miles per hour. In other cases, it can be over 100,000 miles per hour.
Now, man, one of those situations where lots of questions are coming together all at the same time. So let's get back to the sort of the categorization, because I think one of the big problems with this whole thing is that everything's got so many names.
Yes.
It is like a person from Vancouver Island's names for rain. So when it's a big ball of rock out in space, that is an asteroid.
Yes. When it is a frozen body out in space that is more volatile than rock, it is a comet. And there are objects where people argue if it's a comet or a rock based on does it have a tail or not if you put it next to the sun.
A comsteroid.
Yeah.
An asteromet. So those, that's when it's out in space. Now, if it's really teeny tiny and it's moving very quickly, it is a meteoroid.
If it's passing through
the windscreen of the International Space Station.
So a little tiny thing that is a debris bit from an asteroid is a meteoroid. Yes.
Okay, great. So little guy, smashing into the windscreen of the International Space Station, that's a meteoroid.
Yes.
Okay. When that little thing passes into the atmosphere, lights up, and glows, that is a meteor.
Yes.
And when that thing reaches the ground, it is a meteorite.
Yes.
If that thing is very bright, more than 4 magnitude -4 Venus, then it is a fireball.
Yes.
If that fireball explodes, it is a bolide.
Yes.
But if it reaches the ground, we're back to a meteorite.
Yes.
If that thing smashes into the ground and explodes and kills all the dinosaurs, it is still a meteorite.
Yes.
Okay, we got our definitions down. Now we talked about sizes, right? And that's something that I think people, don't even realize, right? Is that meteors they're the size of a piece of sand.
Yeah, most of the time. There are exceptions. We do occasionally, for instance, there was the discovery last week that King Tut had a dagger in his tomb that was made out of carved meteorite, which I find amazing, which means that the meteorite that they used was at least dagger sized. So we do get larger meteorites striking the surface of the planet. We tend to go to places that are constantly eroding the surface that allow them to pop out and be seen more easily when we want to collect them. So people go to Antarctica, and in the summer when the top layer melts off of the ice, walk around the nice shiny surface, pick up the dark stuff. The dark stuff is generally meteorites. We also often can find in the sand dunes where you have blowing sands and deserts, you can also find meteorites a little bit more easily than like walking through the woods. But the kind of incredible thing is there's like order of 1,000 fireballs every single night on the planet Earth, or every single 24-hour period on the planet Earth.
Yeah, it's terrifying how much of this stuff is actually raining down, and how many of the even Chelyabinsk scale explosions in the sky. There are something like one a year, one every couple of years. I mean, it's pretty amazing how often these things are happening.
And the more detectors we build, the more security cameras we have pointed more up than down, the more we realize this stuff is constantly happening. We didn't notice it a lot in the past because 2/3 of the planet's surface is water. Human beings don't take up the whole surface of the planet yet. We have vast swaths of desert. We have vast swaths of woods that have low population. And for the most part, human beings try to sleep at night and aren't outside looking up. So it's really, really easy for all of these things to go entirely undetected. And so we're still learning how often uh, potentially hitting the surface of the planet things are hitting our atmosphere.
Well, let's talk about colors, because part of the show with them is the sort of bright color that you see, and sometimes like usually bright white, but you can get other colors. So when that piece of space stuff impacts the atmosphere, what is actually going on to make it bright? And then I'd love to talk about why you get some of those colors from some of the bigger ones.
So initially, if it's not that bright, if you're dealing just like with your standard meteor passing through the atmosphere, as it's passing through, you will perceive white. And this is because the parts of our eyes that can detect low light simply go light, no light, and our brain goes white, black, shades of gray. And occasionally, our brain will fill in colors that it knows, but that's not because we're detecting the colors. It's because our brain is smart. Now, as that meteor shooting through the sky becomes a brighter and brighter meteor, the light starts to be able to trigger the parts of our eye that detect color, the 3 different color detecting cells, 4 if you happen to be tetrachromal. And so with these bright ones, we start perceiving color. And there's a lot of different people perceive different things. Colors of all kinds have been seen. And when it's true color, it's due totally to chemistry and occasionally simply our brain making stuff up.
Right. You know what's funny? This is sort of like I'm going to sort of go down a rabbit hole for a second here, which is that, whenever there is a fireball that happens, especially I like to watch for them on Twitter, and usually you'll get this sort of cascade of messages being posted on Twitter when people are actually seeing them. And you will almost right away, someone will post a picture, someone will post a fake picture of some of the nicest fireballs that have ever been seen, but they were completely predicted because they were re-entering spacecraft that we knew were going to happen. And I always see the same kinds of pictures, and so I have to like go on to Twitter and go, that's fake, that's fake, that's fake. But so like if you're lucky enough to know when some of these spacecraft are going to be returning to Earth and you're in the flight path, you get a chance to watch it. Unless it's really large, like Mir, or when the International Space Station finally comes down, you don't want to be anywhere near it.
True. But we do get a fairly good show with the Perseids in August, the Leonids in November, especially in the years right after the comets have refreshed their trails and we're going through that nice fresh trail. In this case, it's icy volatile debris, but some of it is big enough to cause these amazing fireballs and bolides like I saw back in 98. So there is plenty of opportunity for there to be just regular old go out on an August summer night, wear all of your bug spray, all of it, then add some more, and set up a camera and you can catch these things.
Oh, yeah, absolutely. So you just mentioned a bit about the comets refreshing them. So can you go into a little more detail on this? I mean, is there fireball seasons in the way that we have meteor showers?
So it was kind of amazing. Was back at the beginning of the last century, there was actually one meteor shower that was so amazingly prolific that, and it was when the Earth went through right after the tail of a comet went by. So like, comet goes by, comet lights up the sky. Just a little bit later, Earth goes through that trail. And it was causing some reports of daytime observations. It was considered to actually be raining shooting stars.
There's like pictures, yeah, like in the 60s, just these amazing pictures of just like hundreds of thousands of meteors per hour, and I guess a ton of them would have been those really bright ones. The biggest one that I can remember was the 2001 Leonids. I think we've mentioned that a few times in the past. Everyone said it was going to be a good meteor shower, and I went outside, and it absolutely was the most stunning meteor shower that I've ever seen. It was amazing. There was a meteor every couple of seconds, just zip. Zip.
So the meteor shower that I was just referring to, the song that it inspired is "The Stars Fell on Alabama," which was recorded in 1934. The meteor shower itself occurred in the late 1800s. So. Sorry, it occurred in the early 1800s in 1833. It was the Leonid meteor shower. And so it was considered the night the stars fell, and it led to this jazz standard being produced.
So let's talk a bit about what your job is when you see a fireball in the sky.
So,
Like,
what a
first,
lot of,
obviously, tell everyone around you, whoa, do you see that? Oh my God.
yeah,
Yeah. And then, if you happen to have your camera out and you're taking a long duration photograph, then by all means, don't kick your camera over because you're going to get a really amazing picture. Once that's all done, though, you have a job. You've been deputized.
it's true. So the American Meteorological Society actually collects data on this. So if you go to amsmeteors.org, they have a form, because there's always a form. They have a form that you can fill out to report seeing these fireballs. And so there are folks out there that, well, first of all, how far was the meteor seen? What time was it seen in different locations? And this information, especially if you have a dash cam or some other thing that just happened to catch it and have a timestamp, security cameras are another way that we catch these things. It can allow us to track down, and by us, I mean folks like Jeff Notkin and the other meteor hunters out there, to go out and find these fresh samples from space. And there's actually a whole lot of science to be found in these rocks that had a rather terrible existence.
All right, well, let's talk about the science then, because as you said, sometimes they explode and actually survive and reach the ground. What goes into sort of finding them and what's important there?
So we have two different situations that we're looking at. First of all, you have things like Chelyabinsk, where that sucker explodes before it hits the ground. That was one heck of a fireball and bullet. Now, in this case, you actually end up with shrapnel kind of scattered all about. And that shrapnel, each piece of shrapnel, is a chance to understand our early solar system a little bit better. Now, even better than shrapnel is those times where you get a larger chunk that makes it all the way to the surface of the planet. Because those larger chunks have the potential to have pockets of volatiles inside of them, pockets of ice that turns to gas, stuff that, well, gets at what is the ratio of different types of oxygen, what is the ratio of different types of carbon in this gas that was trapped when the rock formed back when our solar system formed, or even more excitedly, when that rock formed on Mars. What's the atmosphere on Mars? We sampled the atmosphere of Mars using rocks sent to us from Mars before we ever got a space probe there.
There was one that landed in a lake in Alberta, I think, a couple of winters ago, and the Chelyabinsk one too, right? A big chunks of it went into a lake, which was really lucky because then it's a little more preserved. In the one in Alberta, it didn't go all the way through the ice, and so they were actually able to go out when the shortly after it had fallen and dig up the ice and actually get these perfectly preserved meteorites from the ground. Chelyabinsk. We've got a piece of Chelyabinsk.
Yes.
Thanks to our good friend Richard Drum, the astronomy bum, which is kind of amazing.
Yes, I actually
have you got your Chelyabinsk meteorite right there?
I have it right here, embedded on a foamy that has a picture that was taken by one of the cameras that just happened to get lucky and record the impact, explosion, bolide come fireball. So yeah, bad things happen. If you hear a not if you hear, it's too late when you hear it. If you see a fireball, there's two chances you'll hear it. One is there's going to be a sonic boom, which is what happened at Chelyabinsk. You don't want to be near glass when that sonic boom occurs. And there's another case of hearing it, which I think is what you were talking about earlier. Now, that time that you think you heard a fireball, what did you experience?
It sounded a little like kind of crackling in the air. A little bit of like pop crackle sound.
So there's a lot of different reports of this kind of electronic noise, and it's always reported by people who are near metal. So there's this idea that we can't fully understand the physics. It's just something that gets reported a lot, and different people publish papers on what they think it might be. But as far as I can tell, we don't have a conclusive understanding of the entire process that leads to hearing it. But it's called an electrophonic sound, and it has something to do with the ionization, the charge buildup, creating a crackling that we can hear, sort of like you can sometimes hear St. Elmo's fire.
Oh, that's really cool. So if you want to increase your chances of getting a chance to see a fireball, I mean, not just a regular old meteor, but you want to see a fireball, what should you do?
Look up.
Okay, well, that's the show, everybody.
It's so if you think about it, you're only going to see these if you're outside looking at the sky. I've seen, other than that one time I saw the Leonids, I've seen a bunch of fireballs while I was out driving in wide open spaces. I live in the American Midwest. We do flat really well, which means we can see far out, great distances, lots of sky. And so driving, it gives me a large swath I can view. But I'm still not seeing the whole sky. I'm missing anything that is above me or behind me. The best thing you can do is find yourself a great hammock and have it nice and taut so that you're looking straight up. Go outside, stick a favorite podcast or audiobook in your ears, and just look at the stars for things that, well, move faster than planets.
Yeah, I mean, this is one of those things that you get out of it what you put into it. That the more time you spend out in the nature, looking up and appreciating the wonder of the cosmos, the higher the chances you are of seeing a really bright fireball. And that, one in, I don't know what the percentage is. Let's say 1/10 of 1% of all the fireballs. So if you see whatever 1,000 meteors, you're going to see one fireball. Like, it's just a numbers game. So get out there and see. Don't live on the west coast of British Columbia, I think, is good advice as well, because
you need clear skies.
all we have is rain. Every time I'm like, I'm going to get a telescope. No, I don't need really much of a telescope. I've got a good pair of binoculars and a small telescope, but yeah.
So it's a really one of those cases of these things happen 1,000 times a night. But if you don't look up, you're never going to see one. And even if you go out during a meteor shower, it doesn't necessarily change your probabilities all that much for a lot of meteor showers, because a lot of meteor showers are the less than magnitude for not quite as bright, little, just normal meteors shooting across the sky. These really super bright bolides and super bright fireballs, those are there every night. You just need to go out and look.
There you go. You can't see it if you don't get out in it. So that is really the lesson we've learned all the time. Is that
it's true.
If you just stay inside, play your video games, you won't get a chance to see, watch your TV, you won't get a chance to see the wonder of the cosmos that's unfolding around you all the time.
Now, one final thing before we go away is you don't actually have to have eyeballs to perceive the fireballs. They just help. If you take a radio outside, not Sirius radio, but an actual honest to goodness FM radio, if you take a radio outside, tune it to the space between stations, that crackly, staticky, you'll sometimes hear significantly louder squeals and pops. And those are the audio versions of the fireballs as they streak through the sky and reflect back radio stations that are greatly Doppler shifted and other different things that generate this radio noise that allows us to get it perceiving these fireballs in a completely different light.
Yeah, and we love to hear your reports. So, on the comments on our videos and stuff, by all means, jump in. And if you've had a chance to see a fireball in your life, we'd love to read about it. So, well, thank you so much, Pamela. And we'll talk to you next week. We're down to just a couple of shows before the hiatus.
It's great. And we're going to miss you, Preston. So for those of you who don't know, I'm just going to put this into the actual show. Preston Gibson, our audio producer who's been working with us for years and years and years, doing an amazing job, is going to retire from working on our show so he can work on his professional career and, well, get a few hours back in his life to have a life. We're really proud of him for everything he's accomplished, and he will be sorely missed. And we're really greatly proud to see what he's accomplished. So I'm going to shut up now.
Thanks, Preston. What she said. All right. Thanks, Pamela. We'll see you next week.
Bye-bye.
All right. I need to stop that. I need to save that. I need to export that thing over there.
Yeah.
And then that's me looking up at a monitor.
Me too.
Have you got your monitors stacked on top of each other?
I have one turned sideways.
Oh, that's cool.
Mm-hmm. Especially for Twitter. It's also amazing for coding because
you're just a big long screen. Maybe I'll do that. I'll turn all these monitors. I don't think it'll fit.
So the way Kyle did his is he had a 3-monitor system where he had his biggest monitor in the center and the 2 slightly smaller monitors were turned sideways to the left and right. He now has 4 monitors set up like yours and then a lower down one that's more like one of those cashier monitors, kind of at a weird angle, that I think he uses for tracking conversations.
That's cool, though that would just fritter your brain. I couldn't do it. Okay, so now is the time when we'll take your questions about space and astronomy, and literally we will talk about, we'll talk about what we talked about in today's show, but we'll also just talk about other stuff in space and astronomy. So, Guido Bieber asks, is the outro on the podcast Preston's voice?
Yes.
Yeah, it is. Yeah, I think it was mine for a while, and then he was like, you guys need to make some changes to the outro, and then we didn't get back to him, and he's like, fine, I'll do it myself, and then he just took over. So,
and he has radio voice.
Yeah, absolutely.
And there's been several times where my computer or Fraser's computer decided to eat audio, and we've had to steal it from YouTube or something, and it's been Preston who's fixing that for us.
And I saw a conversation that was going on the YouTubes while we were doing the show. The people were asking about how can you see satellites and what kind of resolution can we get?
Oh, heavens above.
Yeah, heavens above is great because it'll tell you when satellites are going to be going overhead, and you want to get the one you want to get, or NASA will tell you when the International Space Station is going to go overhead.
Yeah.
And then you take out your binoculars. This is the cool part, right? You take your binoculars out, like a nice pair of binoculars. I wish I brought mine down, but I've got a 15 by 75, so they're good astronomy binoculars. And you can actually see the TIE fighter shape of the International Space Station as it's going overhead. And you just do this yourself. Go on, get binoculars, look up at the sky when the space station is going by, and you can see the little shape of the actual, the solar. You're seeing the solar panels, which is just stunning. Other people are mentioning you can see iridium. So the iridium satellites, you can predict when the iridiums are going to get this really cool flash in the sky. Same thing. You can actually just, you can catch them in a telescope or catch them in a wide field of view, but you can also just look up in the sky and there's going to be an iridium, and there it is, which is just amazing. Have you ever had a chance to look through a telescope at the space station as it's going by?
No, but one of my friends took this amazing image that I'm trying to pull up from a school. So they used the school's telescope. Now, admittedly, the school has a big telescope, but nonetheless, it's just sort of like that came from the ground, and not just from the ground, but from a suburb of Boston. And so I'm going to see if I can figure out how to screen share this to you, in which case you have to figure out how to take. Oh, if I screen share, it totally wrecks the alignment of things. I'm going to give you the link, and then you can figure out. We're still trying to figure out how to effectively do things on the fly. So I put it in the Zoom chat. Let me know if you want it somewhere else.
Yeah, well, I can't put it anywhere else, but it's what should they search for? Search for Atlantis and the ISS, right?
Yeah. So
Yeah. Well, this
Atlantis and Dexter Southfield Schools, the claycenter.org.
There's a great astrophotographer, a guy named Thierry Legault, and he will sort of travel the world trying to get really crazy lineups of various objects in space. And so he'll do things like he caught the ISS passing in front of the sun during a solar eclipse.
Yes.
Or
during transit.
Or during a Mercury transit. Yeah, that's right. Or the Venus transit. I think he also caught. Anyway, he caught like the Atlantis docking with the space shuttle. Docking with the ISS during going in front of the sun and things like that. And he'll run the calculations, and he knows exactly where to go on the whole planet to get these things to line up like this. We tried to get someone to bring a live pass of the ISS into the virtual star party. There's this great guy who out of Florida, and he built a special rig so that he could track the space station as it went by and stay tracking it as it was going by.
Merrick did that at Dexter Southfield as well, and they actually have the technology that they can also like follow SpaceX and things like that.
Yeah, you can see, like, after a rocket launch, you can actually go out and watch things like the Dragon capsule approaching the International Space Station, and you'll see two stars, but you'll see two stars pass in the sky. And I mean, I was going to mention this. You said that for it to be brighter than Venus, the ISS is the brightest object in the sky, right? So it's
you have
brighter than
iridium
Venus.
flares periodically.
Sure, but when the ISS is going overhead, it is brighter than Venus, which is amazing.
Yes.
Cool. So that is, and you know what? I'm going to do a little plug here. One of our writers for Universe Today, a guy named Bob King, is working on a book that's all about this. It's all about seeing the night sky with the unaided eye. And so there's going to be great projects like this that you can do. Jack asks, Jackman is Jack. I hate Fraser, love the videos. Do you think you guys could ever do a documentary? Well,
Can you pay us?
Yeah, well, aren't we doing documentaries?
Well,
just
yes,
5-minute long documentaries. We'd love to. It's just a matter of resources, right? And getting a chance to, it's just budget. So the budget that I can afford is I write the videos and shoot them with Chad and post them to Universe Today, because these are all things that I have under my control, right? Absolutely, if somebody wanted to give us more money and introduce us to 3D animators and we've done all the pieces. I could write. What's writing an hour-long show? It's just a little more time. Going, and we've done interviews with people and brought them into some of our videos. Like we went down and interviewed Emily Lakdawala and Mike Brown and people like that. So these are all, I'm ready. All right. Let's see. What else have we got here? Poor Thomas Draniker says he's too far north to be able to see the International Space Station.
Oh, I hadn't even thought of that, but that's a problem.
Yeah, that's a trip, buddy. You gotta head south. Okay, so Brian Yoko asks, a few shows back, the only explanation for bruising of the cosmic microwave background was the multiverse. Are there any other theories to explain the anomaly? And I guess this is the cold
there's
spot.
Lots.
Yeah, Yeah. Almost
So,
any of them are more reasonable than the multiverse, right?
so the different ones that I like are ones that say there is either a disordinately large blob o mass that caused the difference, or that there's something intervening that we haven't figured out how to account for. So basically, explanations of it's stuff, but it's weird stuff in a statistical sense of weird stuff.
Statistical sense of weird stuff. Yeah.
It's not like some new unusual form of matter. It's just there shouldn't be a blob that big there, but hey, there is because the universe is cool and awesome and weird.
Let me see if there's more questions. Brian wanted to know if he could ask questions from a previous show. Absolutely. You can ask questions about previous shows. You just did. It was awesome.
And Eric Schneider just asked, any updates on next year's eclipse party in St. Louis? We have reserved a block of hotel rooms. I do not have the code to share, or I would have put together a website. We're currently in end of year fiscal closeout at SIUE. So the poor innocent human being whose job it is to help us coordinate with the hotel is currently trying to close out our budgets for the year. Once she comes out the other side, I'm going to get all the information we need. So just to know, we do have the hotel rooms, and that's the most important part that matters.
Cool. I'm excited. It's going to happen. We're going to see an eclipse.
It's true.
Yeah. I'm totally stoked. Okay, let's see if we got any more questions. Come on, hit us with your questions, people. Susan Hunter says that a large part of the meteors were visible on the East Coast in the 19th century. I don't know if that was there. Yeah, okay. I mean, the thing is like the leading trail of the Earth, right, is what's hit. Sometimes as the Earth is passing through these comet tails, the leading part of the Earth is what's smashing into these tails, and so whoever is lucky to be there, they're going to see the highest chance. So whenever there's a meteor shower, you want to go to the place on Earth that's going to have the largest peak. Right.
Yeah.
Whatever is the bow of the Earth that's going into this cometary tail to hit the peak of the tail. There is a best place on Earth, but in many cases it's not worth getting on an airplane and going and visiting.
So I see Margot and James talking about how CosmoQuest can produce a planetary map. Yes, we do have the technology. However, there are some amazing planetary maps out there already, and they're so good. Why create a new one? And Stellarium is free for your desktop, and it's open source. Yeah. And so go Stellarium.
You can go into the future, you can go into the past. Yeah, Stellarium is great. Like I've done the Phases of the Moon app, published that for Universe Today just because I wanted a better
and that was unique.
But and I've thought about doing for us to publish something that's in that sort of star chart realm, but Stellarium is the best. It is the bomb, and they've got an app-based version of it, the computer-based version of it. It's so great. I think I would be pretty hard pressed to want to try and take that on. Even there's Google Sky. There's the
Worldwide Telescope.
Microsoft has the Worldwide Telescope, and then there's of course the Universe Simulator, which is a pretty fun thing to use. Okay.
So I saw a request for a summer sci-fi reading book. If you want light and fluffy, I'm scanning because I don't do light beach reading sci-fi. I tend to do the world is ending, everyone run for cover sci-fi. If you don't mind your sci-fi dark and scary, Seven Eves by Neal Stephenson is all kinds of fabulous, as is Aurora by Kim Stanley Robinson. If you have already read Mars, if you haven't already read Red Mars, Blue Mars, Green Mars, go read those.
Yeah.
What's wrong with you?
And The Martian.
And The Martian. Now
Yeah.
that one, well, now that's still kind of here.
That is
Take your
light.
sci-fi with.
Yeah.
It is more light. I'm like scanning through page after page of books, and wow, I read dark stuff. Um,
Wow. Ready Player One, if you want some light
yes,
summer
but that's not
reading.
sci-fi.
What do you mean it's not sci-fi? It's totally sci-fi. Ready Player One.
Yeah,
It's all about virtual
I get.
reality and
Yeah, I
yeah.
guess it's dystopian. To me, it was cyber fiction, but okay.
I haven't read Seven Eves actually yet. I want to. Neal Stephenson is always a good time.
If you want something totally light with a touch of fantasy, uh, the YA book Cinder, which is by Marisa Mayer, is like the I just read something and I need to like rinse my brain. It's the sci-fi equivalent of eating a saltine to clear your mind.
Sean Kenny recommends Lucifer's Hammer, which I agree. It's a great book. I really enjoy that
Mm-hmm.
combination of writers. It was Pornell and Niven came together and did that, and they did a bunch of other books as well. They're sort of the
Lock In by
perfect.
John Scalzi. Again, not happy.
Yeah, you just sad
I
and
have a
depressing.
problem.
No, there's a kind of book that you like to read.
Red Shirts by John Scalzi is hilarious
Yeah,
and dark at the same time.
chicken soup for the soul, says Rob Taylor. Cool. Any other questions? Any other questions? And you can put a little question mark in front of the question, and then we'll be able to get at it there.
And I'm just going to keep
Any
scrolling
David
until
Joseph
I
Wesley
find.
asks, any naked eye visible comet possibilities on the horizon? Not that I'm aware of. Which is
But these
weird
things
because the
crop up.
universe owes me a comet. So, I don't know. It's weird. The universe really needs to pay up.
It's true.
Thomas Channeker is saying Aniara by Harry Martinson. Haven't read that. Contact by Carl Sagan, of course. Yeah, can't go wrong with that.
Moon is a Harsh Mistress and The Water Knife by Paulo Bagagalupa. So Moon is a Harsh Mistress by Heinlein
Yeah.
and Water Knife by Paulo Bagagalupa. Both get you really thinking about water rights in a way that if you live in California is really eye-opening.
Yeah. Larry Beckham recommends Childhood's End, which was a TV show.
Yes.
Did you catch the TV?
No.
It was a special on the Sci-Fi Network this
Okay.
this year, and it was good. I liked it, and I knew Childhood's End is one of my favorite sci-fi books, and really makes you have these deep, sort of unsettling thoughts about what it will mean to really encounter a spacefaring civilization. So, cool. Man, there's tons and tons of great recommendations. David Dunn says the universe also owes me a supernova. No, the universe sent me a supernova, and I missed it.
Oh.
Yeah, no, this is the classic story that we were watching. We're doing a virtual star party, and a supernova appeared, and we didn't notice. And then someone announced the discovery the next day, and we went back and looked at our pictures, and yeah, there it was, right there in the picture. But we didn't notice. In fact, yeah. Anyway, I can't even go there. More repressed memories at this point. Cool. Okay. I think that's it then. I think we're sort of reaching the end of our hour. Thanks again, Pamela, for bringing the brain. Thanks to all of the fans for watching live. I really enjoy getting a chance to hang out with all of you. We will see you all next week. Are we going to record at this time? Friday?
I believe so.
We good? Yeah.
Yeah.
You're gonna. I'm going nowhere for the rest of the summer. Except for the beach.
I'm going to go to a star party at the end of the month.
Cool. And then you're gonna be, I guess, Dragon Con at the end of that's when the whole party starts back up again. So
Yep.
cool.
And no Dragon Con for you this year.
Nope. No, beach.
will be
And
missed.
well, but we're then going to meet up in September for the Osiris Rex launch.
It's true.
Yeah, so that's going to be the next big thing. That's my big September activity is
Yes.
watching my first rocket launch. So, okay, cool. Well, thanks everyone for watching. Thanks Pamela for joining me this week, and we will see you all next week.
You're awesome.
Now I try to stop this. Everything's goodbye, all the internets. Stop.